Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 24, Episode 92, full broadcast on the 11th of August 2021. Coming up on SpaceTime, the shortest ever gamma ray burst, approval given for Australia's second launch site, and more delays for Boeing's Starliner spacecraft. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered the shortest ever gamma ray burst. The huge blast, identified as GRB 2008-26A, was caused by the supernova implosion of a massive star in a distant galaxy. The blast was so powerful, it emitted 14 million times the energy released by the entire Milky Way galaxy in the space of just 0.65 seconds. Most gamma ray bursts are usually more than twice as long, producing what are usually described as the brightest and most energetic events since the Big Bang. Astronomers divide gamma ray bursts into two broad categories based on their duration. Short-period gamma ray bursts blaze into life in less than 2 seconds and are thought to be caused by the merging of neutron stars in a binary system. Neutron stars are the densest objects in the universe other than black holes. They're formed out of the core collapse of massive stars at the end of their lives, compressing a stellar core more than 1.4 times the mass of the Sun into an object just a dozen or so kilometers wide. The material of neutron stars is as dense as the nucleus of an atom, and a single teaspoon of neutron star material would weigh as much as Mount Everest. As well as their incredible density, neutron stars are also intensely hot and possess magnetic fields millions to billions of times stronger than that of the Earth. Longer duration gamma ray bursts, those lasting more than 2 seconds, are thought to be caused by the implosions of some of the universe's most massive stars. At the end of their lives, stars run out of the hydrogen that sustains nuclear reactions in their cores, the thing that makes a star shine. Without the stabilizing pressure of these reactions, stars can't fight gravity, and they collapse into an exotic stellar remnant. The mass of a star determines its fate. Stars smaller than 1.4 times the mass of the Sun will shrink into white dwarfs, while larger stars collapse into neutron stars, and the largest stars of all collapse entirely, forming black holes, an object with such intense gravity nothing, not even light, can escape. When a star is massive enough to collapse into a black hole, matter swirls towards the black hole around an accretion disk, and some of it manages to escape in the form of two powerful jets that rush outwards at almost the speed of light in opposite directions, perpendicular to the accretion disk. Astronomers only detect a gamma ray burst when one of these jets points almost directly towards the Earth. Each of these jets is drilling through the collapsing star, producing a pulse of gamma rays, the highest form of energy. This can last for seconds to minutes. Following the gamma ray burst, the disrupted star rapidly expands into a supernova. However, a report in the journal Nature Astronomy suggests that the incredibly short burst of GRB 2008-26A appears to have been created by a supernova event rather than a neutron star merger. The study's lead author, Thomas Amanda from the University of Maryland, says the discovery sits on the brink between a successful and failed gamma ray burst. Amanda and colleagues believe it was so short despite being produced by a supernova because the jets of the gamma rays that emerge from the collapsing star weren't strong enough to completely escape the star, almost failing to produce the gamma ray burst. Long gamma-ray bursts are associated with a specific type of core collapse supernova which lacks spectral signatures for silicon. That's because they're hypothesized to have lost more of their initial envelope, especially helium. And these are usually referred to as strip core collapse supernovae. The authors used the Gemini North Telescope to obtain images of the gamma-ray burst host galaxy 28, 45 and 80 days after the burst was first detected by a network of observatories, including NASA's Fermi Gamma-Ray Space Telescope. The event also appeared in instruments aboard NASA's WIND mission, which orbits a point between the Earth and the Sun located 1.5 million kilometers away, the Mars Odyssey spacecraft, which is orbiting the Red Planet, and the European Space Agency's Integral spacecraft. Gemini's observations allowed the authors to study the event's fading multi-wavelength afterglow and the emerging light that followed the blast, allowing them to spot the telltale rise in energy that signifies a supernova, despite the blast's location in a galaxy 6.6 billion light-years away. If the blast was caused by a collapsing star, then once the afterglow fades away, it should brighten again because of the underlying supernova explosion. The discovery suggests that since astronomers observe many more of these supernovae than long gamma-ray bursts, most collapsing stars fail to produce a gamma-ray burst that breaks through the outer envelope of the collapsing star. Astronomers think this event was effectively a fizzle, one that was close to not happening at all. The discovery of GRB 2008-26A suggests that some neutron star merger gamma-ray bursts are actually supernova-caused gamma-ray bursts. This report from NASA TV.
NASA's Fermi Gamma-Ray Space Telescope has spotted the shortest burst of gamma rays ever seen from a collapsing star. It challenges the traditional classification of gamma-ray bursts, also called GRBs. Short GRBs, those lasting less than 2 seconds, are thought to occur when orbiting objects like neutron stars spiral together and merge. Longer bursts come from massive stars at the ends of their lives. A black hole forms at the center of the collapsing star. It drives long-lasting jets that drill through the star, producing gamma rays when they emerge. The star then transforms into a supernova. On August 26, 2020, Fermi detected a GRB lasting about 1 second. Instruments on other spacecraft saw it too, including NASA's WIND and Mars Odyssey missions. They helped narrow down the location to a patch of sky in the constellation Andromeda. Less than a day after the GRB, astronomers identified a fading source of visible light using the Zwicky Transient Facility at Palomar Observatory. This was the burst's afterglow. NASA's SWIFT satellite soon recorded X-rays from it, and within days, ground-based radio telescopes observed it too. After a few weeks, when the afterglow had decayed, ground-based observatories confirmed the presence of a brightening supernova. This means the GRB must have come from a massive collapsing star, not a merger. Astronomers think this burst, called GRB 2008-26A, was on the verge of not occurring at all. About 6.6 billion years ago, a massive star in a distant galaxy reached the end of its life. Its core collapsed and formed a black hole, which launched near-light-speed particle jets through the star. But just as they breached the surface, the jets shut down, producing a surprisingly brief GRB. Astronomers think it's likely some short GRBs they've detected are misclassified as mergers, when instead they're really bursts from jets that nearly failed to drill through collapsing stars. We only detect GRBs when the jets aim in our direction. Even accounting for this, long GRBs still occur at a lower rate than the supernova type associated with them. This means most collapsing massive stars likely fail to produce long-lived jets, dying, at least from the gamma-ray perspective, with a whimper instead of a bang.
This is SpaceTime. Still to come, approval given for Australia's second launch site, and more delays for Boeing's Starliner spacecraft. All that and more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
The Australian Space Agency has granted a commercial space launch facility license to Southern Launch's new Whalers Way launch complex, 680 kilometres west of Adelaide. But the license is limited. It will enable Southern Launch to undertake an initial series of 3 rocket tests. As part of a campaign of suborbital flights designed to measure the likely environmental impact of future orbital rocket flights. The granting of a license for the Whalers Way launch complex follows Australia's first commercial launch facility license granted to Southern Launch back in March to allow them to use their rocket test range at Coonabarra near Ceduna on the South Australian west coast. These latest approvals follows a green light given to Gilmore's new launch complex at Boeing on the Queensland north coast. The Gilmore complex will focus on equatorial launches, while Whalers Way will handle polar launches, and Coonabarra will be used to test rockets and launch systems where hardware recovery is needed. This is SpaceTime. Still to come, more delays for Boeing's Starliner spacecraft, and later in the science report, ancient bacteria and phages discovered in a Tibetan glacier. All that and more still to come on SpaceTime. The crucial Starliner orbital test flight 2 to the International Space Station has now been postponed indefinitely due to more technical issues. The test involved Boeing's Starliner CST-100 spacecraft, which is designed to launch aboard an Atlas V rocket and transport crew to and from the International Space Station as part of NASA's Commercial Crew program. A second crew transport system operated by SpaceX using its Dragon capsule mounted on a Falcon 9 rocket has already been operating successfully for over a year under the program. A second Starliner orbital test flight was needed after the first test flight failed to reach the International Space Station back in December 2019 and was almost destroyed during re-entry following a series of computer software glitches. NASA later identified 80 corrective actions Boeing needed to undertake before another test flight. The unmanned test flights designed to carry samples to the orbiting outpost, undertake an automatic docking, and later undertake an automated undocking and re-entry, landing at the White Sands Missile Range in New Mexico 5 days after launch. If all goes well, a manned test flight will take place towards the end of the year, with Starliner finally joining Dragon and undertaking regular crew transfer duties from next year. This latest delay for the Starliner has been blamed on the detection of unexpected valve position indications on the spacecraft's propulsion system during checkouts when electrical storms passed over the Kennedy Space Center. Boeing teams recycled the service module's propulsion system valves and the Starliner and Atlas V on the launch pad, ruling out a number of potential causes, including software issues. Mission managers have now powered down the spacecraft and rolled the stack back into Space Launch Complex 41's vertical integration facility. The launch had originally been slated for July the 30th, but was postponed following problems with the space station's new Russian Nauka service module, which suddenly ignited its thrusters, moving the orbiting outpost out of alignment. This is SpaceTime.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Fargo, the new virtual assistant from Wells Fargo, makes banking faster and easier. Like this.
Fargo, what's my checking account routing number?
And this.
Fargo, turn off my debit card.
And this.
Fargo, what did I spend on groceries last month?
And that's just the beginning. Do you, Fargo? You can in the Wells Fargo mobile app. Learn more at wellsfargo.com/getfargo.
Terms and conditions apply. Your mobile carrier's availability and message and data rates may apply. Wells Fargo Bank, N.A., member FDIC.
And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has confirmed earlier research showing that using an AstraZeneca jab followed by a Pfizer or Moderna jab for a second shot may be more effective than 2 jabs of the same vaccine. The findings, reported in the journal Nature Medicine, show that combining the 2 different types of vaccines resulted in a stronger immune result than having 2 jabs of AstraZeneca and an equally strong or stronger immune response than having 2 jabs of either Pfizer or Moderna. The authors found levels of spike-specific CD8 T immune cells were also higher with the combo than with either single vaccine regime. But the authors also found that having 1 jab of AstraZeneca followed by the mRNA vaccine resulted in a similar reaction to having the second of 2 mRNA vaccine jabs, which can leave recipients feeling unwell for several days. Meanwhile, a new study shows that people who purposely breach COVID-19 regulations tend to be less open to new ideas, more extroverted, and driven by self-interests. The findings, reported in the journal PLOS One, looked at the psychology, attitudes and behaviours of people in Australia, the US, the UK and Canada. The authors surveyed some 1,575 participants looking at people's behaviours and attitudes towards pandemic regulations. They found that roughly 10% of people were non-compliant. Those individuals were mostly male, and they perceived their social culture as tolerant to differences in values and behaviour. Contrary to the stereotype, most of them were not young, and these individuals tended to engage less with official sources, such as government announcements and news, and engage more in unhealthy coping mechanisms such as denial and substance abuse. The World Health Organization says more than 8 million people have now been killed by the COVID-19 coronavirus, with over 4.4 million confirmed fatalities and more than 205 million people infected since the deadly disease was first spread out of Wuhan, China. A new study warns that some 83% of green turtles and 86% of loggerhead turtles monitored off the coast of Queensland were found to have ingested plastics. The findings, reported in the journal Frontiers of Marine Science, show plastic ingestion rates among turtles were generally higher on the Pacific coast off Queensland than in the Indian Ocean off the coast of Western Australia. The authors say the life cycle of marine turtles might have become a novel ecological trap, where juvenile turtles are trapped in habitats with high amounts of plastic debris. Microbiologists have found 14,400-year-old ancient bacteria and their phages, that is, bacteria infecting viruses, in a Tibetan glacier. Scientists study glacier cores to reveal paleoclimate histories, and there are often microbes trapped in the ice. Researchers found the bacteria in this glacial sample likely originated in soil or plants rather than animals. Glacier ice microbes were largely ignored until the 1980s, when samples in the ice cores from Antarctica's Lake Vostok were examined in detail. Those studies revealed microbial cell concentrations up to 10,000 cells per milliliter. A report in the journal Microbiome shows that the Tibetan glacier viruses have genetic signatures specifically designed to help them infect cells in cold environments. Telstra makes its payphones free for everyone, everywhere in Australia, and Google's upcoming Pixel 6 and 6 Pro to feature the new Tensor CPU. With the details on these stories and more, we're joined by technology editor Alex Harov-Reutt from ITWire.com.
They're a slowly dying breed. I mean, Telstra uses many of its payphone boxes as advertising opportunities, where they have these giant television screen billboards that can display ads. And
Wi-Fi hotspots.
And also for, Telstra Air Wi-Fi hotspots. And, with mobile phone plans as cheap as $10 a month for unlimited calls and texts in Australia to landlines and mobile phones, anybody can afford to have a mobile phone. But people do use landlines when there's been a bushfire, for example, and mobile towers have been affected. The power that goes to mobile towers, if the power lines have burned down, there's about 24 hours of battery power. So in many cases, the landline phone, the payphone, could be the only phone that's available until power is restored to mobile towers. So payphones still serve a useful service. I mean, 11 million calls were made last year, but that's only basically about one call for every 2 people. I mean, there's 25.5 million people in Australia. So the usage of payphones is going down and down. They are used when there are crises, but mobile phones are ever more reliable. So, yeah, clearly if it's costing too much money to go and retrieve the dwindling amount of coins that will be going into those phones, and the phones are there and the cost of making calls goes down to very low amounts for the telcos, it makes sense just to offer the calls for free. And it's not even one of these temporary COVID measures where they'll make it free for a certain amount of time. It's just now free. So if you need to get to a payphone, you can. But I guess in this COVID world, you need to make sure that you wipe the handset and
you've got to find one as well. I mean, they're not that common anymore. They used to be common as muck. Every street corner had a little red phone box, and they originally looked like British phone boxes. Then all of a sudden, they started looking like American phone boxes. Yeah, after that, the cell phone came out, and they all started disappearing one by one. And as you said, now you only see them when they've got advertising on the other side.
And they don't have doors on them anymore. Superman can't use them to sort of try and quickly turn into... That's right.
What about Get Smart? How's he going to reach control headquarters now?
Well, he always had the phone in his shoe, which was the mobile phone before the mobile phones became as ubiquitous as they are today. This probably means that those remaining payphone stations won't be decommissioned. They'll just be there.
Which is good news.
Yeah, which is good news.
Google's new Pixel 6 and Pixel 6 Pro will feature Tensor CPU. Tell us about it.
Yeah, this is Google's new custom-designed CPU. They say they've been working on it for about 5 years. And they're talking about how more and more features are powered by artificial intelligence and machine learning. So Google is very big on that. They actually called their AI and ML chip Tensor some years ago for augmented reality. Never really took off in the way that Apple's augmented reality has taken off. But Apple has made great strides with its own processor. Microsoft has worked with Qualcomm to get Windows working on ARM, and it makes sense for somebody like Google, who does create its own phones. They don't sell anywhere near as many as their competitors who use the Android operating system to power their phones. But Google needs to be able to say, hey, we're just as smart and intelligent a company as Apple. We can make our own hardware as well. So the as yet unavailable Pixel 6 and 6 Pro, which were originally slated earlier this year to only appear in the US and Japan, I'm assuming that's now going to be reversed, and Pixel 6 and 6 Pro will be available all over the world, although that hasn't been announced yet. But they will have Google's own chip, and that's important because the Pixel 4a and 5 we're actually using a sort of a mid-tier Qualcomm processor that weren't using the very latest 888 series Qualcomm Snapdragon, which is the latest and greatest. So Google was trying to sort of reduce its costs by having a good enough processor, but now it's going to have a processor which is its own, and it will be able to more effectively chart its own course. We're going to learn a lot more about it. There is a Google blog post by Rick Osterloh, who's the Senior Vice President for Devices and Services at Google, that you can find online, where he talks about it. But this is their own system on a chip, their own processor. We will hopefully see this appear in future Chromebooks and Android tablets that Google might decide to make. We might see it in a future Google smartwatch, which hasn't emerged from Google despite years of rumors. But it just helps Google to plot its own course, and it'll probably use this technology in some of its own servers and other technologies that it uses to power the entire Google experience, which is the breadth and depth of the internet that we know today.
That's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.